Let's discuss next topic of set theory. It's about function. First definition of function. Let A and B be non-empty set. We have two set. One set is A, another set is B. A function f from A to B is an assignment of exactly one element of B to each element of A. Let A contain A, B, C. These are elements of set A, and B contain 1, 2, 3, 4. So in function, we assign exactly one element of set B to each element of set A. Like let f of A equals to 1, f of B equals to 2, f of C equals to 3. So we write f of A equals to B. Here B is the unique element of set B assigned by the function f to the element A of set A. We can write f of A equals to 1, f of B equals to 2, f of C equals to 3. So exactly one element of set B assigned to each element of set A. A cannot assign to two value of B. So f of A cannot be 1 and 2 both, or f of C cannot be 3 and 2 both. This is not a function. For function, one element of B should assign to one element of set A. But one element of set B can be assigned to multiple element of set A. We can assign 2 to C also. This is a function. If f is a function from A to B, we can write f A implies B. We can also say mapping or transformation. So there is a mapping from set A to set B. Now diagram for function f map A to B. This is the diagram. So f A to B, we can write like this. Here B equals to f of A. A is a element from set A, B is a element from set B. We can write f of A equals to B. Now definition 2, it's about what we call this A or this small b. So we say A is the domain of f and B is the codomain of f. This A is the domain and B is the codomain. And if f of A equals to B, then this B is the image and A called as preimage of B. The range or image of F is the set of all images of element of set A. So set of all images called as range. If F is a function from A to B, we say that F map A to B. So set A called as domain, set B called as codomain. If f of A equals to B, B called as image and A called as preimage, and set of image called as range. And we can say f map A to B. Two functions are equal if they have same domain, same set of codomain and same mapping. Number of function possible from set A to set B equals to B cardinality power A cardinality. How we found this? Let's take an example. Let we have two sets, set A and set B. Now set A contain 1, 2, 3, set B contain simply A, B. Now for 1 there are two possibilities. This one can map to A or one can map to B. So there are two possibilities for 1. Then for 2 again there are two possibilities. It can map to either A or it can map to B. Then for 3 again there are two possibilities. It can map to B or it can map to A. So number of element in set B power number of element in set A, or you can say B cardinality power A cardinality. Here it's 2 power 3. There are 8 different function possible. 1, 2, 3, here A, B, all can map to A. Then in another function all can map to B. Again this is one function. Like this, there are 8 functions possible. So number of functions possible from set A to set B equals to 8 if set A contain 3 element and set B contain 2 element. So number of element in set B power number of element in set A. If number of elements in A or A cardinality equal to m and B cardinality equals to n, then number of different function possible equals to n power m. This is important, just remember this formula. Now one example 1, let f z tends to z, assign the sequence of an integer to these integers. Then f of x equals to x square, this is our function, where the domain of f is the set of integer and codomain will be set of integer that are perfect square. Like f of 1 equals to 1, f of 2 equals to 2 square, it will be 4. F of 3 will be 3 square, it's 9. F of 4 will be 4 square, it will be 16. So here domain will be set of all integers and codomains are all the perfect square. Next, how we can do addition and multiplication in function. Definition 3, let f1 and f2 be functions from A to R. Then f1 plus f2 and f1 multiplication of 2 are also functions from A to R defined for all x belongs to A by f1 plus f2 x equals to f1x plus f2x and f1 multiplication f2x equals to f1x multiplication f2x. Let's see one example that you can understand. Example 2, let f1 and f2 be function from R to R such that f1 of x equals to x square and f2 of x equals to x minus x square. What are the function f1 plus f2 and f1 multiplication f2? First f1 plus f2, it will be x square plus x minus x square. Now plus x square minus x square will be cancelled. So f1 plus f2 will be simply x. Now f1 multiplication f2. X square multiplication x minus x square. X square multiplication x, it's x power 3 minus x power 4. So multiplication will be x power 3 minus x power 4. Next, definition 4, it's about subset of a function. Let f be a function from A to B and let S be a subset of set A. The image of S under the function f is the subset of B that consists of image of the element of S. So we can donate like f of s equals to t, there exists S belongs to S, t equals to f of s. Let's see one example. A contain A, B, C, D, E and B contain 1, 2, 3, 4 with f of A equals to 2, f of B equals to 1, f of C equals to 4, f of D equals to 1 and f of E equals to 1. So set A contain A, B, C, D and E. Set B contain 1, 2, 3, 4. F of A is 2, f of B is 1, f of C is 4, f of D is 1 and f of E is 1. S contain only this set B, C, D. Now what will be image of this subset? So image of B is 1, image of C is 4, image of D is 1. It will be 1 and 4. What are the image of B, C, D? B and D image is 1, C image is 4. So image of subset S will be 1 and 4. In today's lecture, I discussed introduction to functions with some examples and number of functions possible. Number of functions possible equals to B cardinality power A cardinality. In next lecture, I will discuss one-to-one function. If today's lecture is helpful for you, please like, share and subscribe. Thank you.